Welcome to this video on applications of trigonometry. We'll be focusing on navigation and surveying problems, but first we have to go over some definitions. The first definition is course, and in navigation that helps tell you what direction you're going. It is expressed in 3-digit numbers, just like the military expresses military time. We put a 0 if there's nothing in the hundred spot. And this is useful if you are communicating directions. The person listening wouldn't wonder, did I miss that first digit? So if I said 40 degrees, it could be possible that you missed the 1 for 140 or the 2. But if you say 040, then you know you didn't miss anything. The other big difference is that hopefully we have trained you to always start when we're doing degrees on the x-axis and go counterclockwise. However, in this section, we always start at north and go clockwise. So we're always going to start here and go clockwise direction. And if you hear the term compass bearing, it's the same, all the same rules, same meaning. All right, so let's just show how we can draw some of these. So for example, if we have course of 150, we're going to start at north. And we're going to go 150, so we go 90 degrees, and then we need 60 more. So that means we are headed in the southeast direction. If we wanted to break this up, that'd be 90 degrees and 60 degrees. And you remember, just like when we were doing standard position for angles, you always want to have your starting to your ending. All right, then 30 degrees. Again, start at north, and we're just going 30 degrees towards the northeast, and this will be 60 if we want it to be complete and label everything. All right, so let's do an application problem so you can see how this is used. The hardest thing is when it says to and from to figure out starting, ending point. All right, so we have tower T is northeast of village V. So if tower T is northeast of village V, that means this is T and this is V. Now if something says northeast, southeast, southwest, that's assumed 45 degrees. Right. So I am going from V to T. This is 45 degrees, and we know both those coming in are 45 degrees. That 45 degrees is though with that line coming in and the south direction right here. So you have to be careful when you complete triangles that you don't always know if you're coming in directly at a compass bearing. All right, then we have city C is 4 kilometers from T on a bearing of 150 from T. So this is city C, very unique names. And from T, we're going 150. So we just did 150 on the previous one. We'd have 90 and then 60. So this is 60 degrees here. And then this is 30 degrees here. And we come into C. Now, one thing that we often use are the parallel lines and alternate interior angles so that the west-east lines are always parallel no matter where you're at. So if we have 30 degrees, here, we know this is 30 degrees here. And if we have 60 degrees up there, we know this is 60 degrees. Now again, it's made with that compass directions. So it depends how your line comes in to that compass rose. All right, and then we are going to see what is the bearing and distance of C from V. And here's where we have to be careful. So I tried to draw this. So if you look really closely at this section, at this section right here, you'll notice that the line connecting C and V doesn't come in directly east-west. So we can't say that this angle I'm shading in as yellow, we can't say that's 45 degrees because we're not coming in directly at the east. All right, so now let's go back to a color you can see better. We want to find this direction, so we want that length, and to C from V. So our starting point is V, and the bearing then is starting at V. How do we get to that line that goes to C? So that blue little arrow I just drew, that's the bearing we want to do. So first, distance is usually easiest. I always look for law of sines if I can, but for that I would need to know an angle and a side across from it, and we know these two sides, but we don't know the angle at C because we have this little sliver. So we know the 60-degree portion, but I don't know this little sliver that's created from C connecting to V. So I don't know that angle, and same thing here, the yellow shaded angle at V, I don't know that either because we have a little bit left where it comes in to get to the east, so we don't know that full angle. If I were to draw this a little zoomed in, what's happening is I have 45 degrees here, some angle V, and then this angle right here, which I don't know. So together, V and that question mark add up to 45. I know that, but I don't know what that division is. So I have to use law of cosines, and I use the side, and then the other two sides squared, minus those two sides, times the cosine of the angle across from them, which is 45 plus 30, so 75 degrees. All right, and then I just do the calculation in my calculator, and you should get 63.44, and then square root, and we get 7.96 kilometers. All right, so now we know this. Okay, the last step of the question is we want the bearing of C from V. So to do that, let me use the zoom in picture. That's from north to the line that goes from V to C. So it's the 45 degrees plus whatever that angle V is. So the bearing is going to equal 45 because we know that's what's from north to the line going to T, plus the angle V. So the measure of angle V. Now we can easily do that with law of sines because I have 4 across from the sine of V equals 7.96 over the sine of 75. So I did the sine of t with relation to its side, 7.96, and 4 and the sine of v. So if I cross multiply, I end up with 0.4851 equals sine of v, and v equals, it's 29.02 degrees. I'll just round to 29 degrees. So that means our final bearing is 45 plus the 29, because we're going from north, we got the 45, and then to get to that line, we have the from V to C, the measure of angle V, we add those together, and we get 74 degrees approximately. So we have answered the two questions. We have the distance and the bearing of C from V. All right, so that's our first example. Next, just a little notation because we're going to be using this as well. A lot of these, since they're navigation, are discussed in knots. You can think of that just as miles per hour. It's nautical miles per hour. And from the handy dandy Wikipedia, we have the conversions in this little box right here. And I'm going to use the notation for nautical miles as NMI. You can also use those other symbols if you wanted. We're not going to have to convert, but if you're interested in the conversions, they're below. You're just going to label things as nautical miles. That's all. I did have to look up what that cable was. It's another nautical measurement, and it actually has a variation of conversions. It's not a set conversion. All right, so let's go to one other way you could get directions besides bearing, and that's a compass reading. And you could have it's written with two directions. So this is your start, and this is your ending. So where you're starting from and where you're heading towards. And then that's the degree that you're going in that direction. All right, so let me put up all three examples and we will draw these out. Okay, so this one, we're starting at north. Oops. It's a little too thick. There we go. So we're starting at north, going towards east 20 degrees. And again, if we are going to label other things, we know then that this has to be 70 degrees. Sometimes we care about that, sometimes we don't. All right, south 28 degrees west, we're starting at south and going 28 degrees west. So again, if we wanted to be complete, we could fill this in. To get to 90, that would be 62 degrees. All right, and lastly, if you see southeast or northwest or southwest and there's no number in between, you assume it's a 45, that you're cutting it in half. So starting at south, going towards east at 45 degrees. All right, one more example here, and this is, we have a ship, and it's proceeding at a course of south 70 degrees east for 2 hours at 20 knots, then changes south 40 west for 2 more hours at the same speed. How far are we from our starting point? All right, so we are going south 70 degrees east. So again, draw it as best you can. We know this is 20 degrees and the direction made with the south is 70 degrees. Oops. I don't think I'll connect with my picture. Let's make this a little more like 20 degrees. There we go. There we go. And we are going at a speed for 2 hours of 20 knots. So just like if it's miles per hour, if we were traveling for 2 hours at 20 miles per hour, we would just multiply those together and we get how far we went. And this, because it's in knots, we're in nautical miles. So we are 40 nautical miles. Now again, because of alternate interior parallel lines, we know that this is 20 degrees made with the west, and this is 70 degrees. It all depends which ones are going to be useful. I usually tend to erase them if I find out they're not going to be part of my triangle or they'll confuse things. All right, so then we change course and we go south 40 degrees west. So almost cutting it in half. So this is 40 degrees and this is 50 degrees then. Not quite to scale, but close enough. And we go 2 more hours, same speed. So again, we're 40 nautical miles. and then we return back. Now here's where sometimes problems can arise. Notice I'm not coming in straight north-south. So this 70 degrees is not the measure of the angle in the triangle. We don't know what this angle is because we have this little sliver right there. So that angle we don't know. And we just want to find how far are we from the starting point. So we want that measure. Now if you just look at this quickly, it's like the previous one. We don't have a side with an angle across from it known, so we can't do law of sines. However, we could use a little geometry and actually have that measurement. If you don't think of that, law of cosine is perfectly valid. You could do the x squared equals 40 squared. And if you like law of cosines, you can just go straight to this. And you should get the same answer. However, if you look at this, two sides are the same. We're an isosceles triangle. So we know the two angles across from the two equal sides have to be the same. Therefore, I can figure out how much I have left, because that one angle, we have 20 plus 50, so we have a 70-degree angle. And we have 110 degrees left for the two angles. Means both angles are 55. And now I could do law of sines. So I have 40 over the sine of 55 equals x over the sine of 70. Cross multiply, and I get 37.58. I just tend to go out quite a few decimal points just until I get to the final answer. And then x equals 45.89 nautical miles. And you should check that should be bigger than the other two sides since it's across from the biggest angle. And that is all for this lesson. Good luck on the practice problems.